Namaskar and welcome to today's presentation on implementation of integrity management system to defeat the corrosion threats. First of all, I should thank Mace for allowing me to speak on this subject today. So whatever I speak today, it's purely on my personal experience and whatever the qualifications I have and whatever I'm doing it, nothing to do or resembles with my organization. First of all, let us understand what is pipeline integrity. So there are so many definitions available in pipeline integrity. For examples, 32 comprehensive definitions are available from various authors and all. But what I like the best and very easy one to understand more easily is a comprehensive, systematic and integrated process that includes all the activities that are required to prevent a failure, because that is what I think our main objective. So if you see this picture, I think it answers so many words, because I call it a very, very important picture, which is seen and unseen. What you see is very small, but what is hidden behind is very big. So that's where I think the integrity come into picture. So let's think what happens if there is a major failures, because we are all as operators or a general public, we are concerned about the failures. So let's see that I think what happened if there is a major failure or major rupture that take place. It can be a loss of life, the loss of property, and the damage to environment, because all three can happen, or maybe one of the things can happen in any way, because there is a loss. So our job as integrity management engineers is to prevent all these things, the failure, and to safeguard the public. Now come to the few elements of integrity management. So integrity management is very clearly defined very well in ASME 31.8 2004. And even now in 2012, the Petroleum and Natural Gas Regulatory Board has already notified the regulations for integrity management. It covers very simply, very easy to understand and very easy to implement also. In fact, there is not such a complex thing, integrity program. So it comes into the 5 elements mainly. One is integrity plan, and second is the performance, communication, management of change, and quality control. These are all the key 5 elements we keep talking on this, because this entire the process runs based on PDCA cycle: plan, do, check, act. So it's as good as that, like what we follow in our QMS. So if you see that entire integrity, the program, it is defined in a process flow. It's very simple. Entire the integrity management program runs only in this flow diagram. If we can go through around, and then everything is lying as a headlines here. The first most important thing is identifying the potential pipeline impact by threats. That is what we have to do the first. Is what are the potential threats to the pipeline project or the segment or the sections, whatever you call it. For that, what we need is the data. So where do we get the data? So who is responsible for this data? What is authenticity of this data? There's so many issues are there. You need the right kind of information to take the right decisions, because you may be having a lot of the data which may really not useful, because there is a lot of the data is available across the company, across the departments. Is it really authentic? Is it the final one? Is it the right one? So that's where I think entire issues do come. If you see that this picture, when we want to really apply proper integrity management, so we need to have a comprehensive overall picture in your mind. So like the basic information of the pipeline materials, what type of coating you have, what type of soil conditions you have, what is the profile of the pipeline, and various other data, like once you start the baseline data like ILI or the geometry or as-built data. So if this information is made available, then only we can able to start the integrity process. So once you have this kind of information put together in the proper format for the right kind of decision, then you should start looking after the risk assessment. So what is risk assessment? So risk assessment can do the lot of things for the integrity engineers. So first one, it will give an idea where will the next failure will happen, because it will just giving an indication, because it doesn't tell anything exactly. Where are the hotspots? Because you cannot look entire the pipeline project, because you have to identify what is hotspots in that line where you need to give your attention. How many failures can take place, because it gives some idea. And how best you can use your resources, because you have limited resources, you are not given the resources to take care of entire the pipeline. So you have to prioritize your activities, and accordingly you can do the failure analysis, and then you can prevent a failure. So even whatever the best risk assessment you do it, the risk cannot be zero. So you have to be very, very careful in doing this risk assessment. So after carrying out this risk assessment, then you apply threats. There are 22 threats identified by 31.8s, where you can apply each and every threat. If it is applicable, okay. If it doesn't applicable, you just go to the next. So you apply all the threats. If it is done, you go to the integrity assessment, then do the response and to the mitigation integrity activities. Otherwise, you go back to the initial phase, and then you can do again the required data, and then again apply the risk assessment, come back. So what is integrity assessment? Integrity assessment, there are three main types we have identified. One is the pipeline hydro test, that shows the integrity of the entire pipeline system, so that we can commission safely. Another one is ILI, we call inline inspections, so which if you can do it in the beginning, that as treated as a baseline, or it can very well done at 5 years or 10 years, because 10 years is mandatory as per Indian regulations is concerned. The third integrity assessment methods is direct assessment. You can have external corrosion direct assessment, internal corrosion direct assessment, stress corrosion cracking method. You can apply whatever the methods best suitable based on the pipeline, life, and other actual issues. If you see the failure causes that pie chart is identified. So there are 35% the damages are caused because of third party areas, which is beyond the operator control. 25% is mainly because of corrosion, because this is a big area and big concern. Either it may be because of internal or external, whatever it may be. 25% of the failures are because of corrosion. So we need to be very, very careful in dealing with that. So after this integrity assessment is done, then you have to have the response to the integrity assessment. Okay. Now let's go back to the threats. As per the standard is concerned, there are 22 threats is identified. 21 actually really the threats identified. One threat is called as a unknown, because there is something that I think which you so far is not identified very specifically as a root cause. So it is been identified as a unknown. So the program of integrity management is given in two types. One is the prescriptive type you can apply, or you can go on the performance based type. So prescriptive type of the program is very, very conservative, but easier to implement, because you have defined the frequency, like what you do for the CP readings, when you do it geometry, when you do it ILI. So when you do the Pearson survey, because there are various activities is very clearly spelled out, and you have to just do it. And based on that implementation of this, so you can do some corrective actions and mitigation actions. Second is the performance based, which is more flexible but requires significant data analysis and experience. We are just very recently started this integrity program in India. So we need some maturity in implementing the integrity programs purely on the performance based, because performance based means if you find it's a need, you may be doing it more frequently. If it is not required, you may don't do it. So that may not bring very clear confidence on this area. So it's better to go on the prescriptive type as of now. But operator have a right to select either of the programs based on their confidence level. So this pipeline threats of 21 and 22 is categorized into mainly three areas, into One is time dependent and time independent and stable. So that's what it has been categorized. So let's understand what is a time dependent we're talking about. Time dependent mainly can impact is one is external corrosion because it's related to the time. Over a period of time, the corrosion can increase, and then there's the wall thickness will reduce, then there's a probability of failure will increase. So similarly, internal corrosion that also the T1 it may not affect the pipeline, but the more the usage of the pipeline and the age, and there is a failure of due to internal corrosion, and stress corrosion cracking can take place even at the earliest time of 3 years or 2 years also, it can make it a failure. So we cannot just simply say that I think only this can happen after 10 years or 15 years. So all the failures, all the corrosions can fail even very as early as 2 to 3 years. So there's not be a surprise that how it can happen. So if you see here the pipeline failures because of time dependent, 25% is because of corrosion, and 21% of the failures have been seen because the stress corrosion cracking, because that has been observed in some parts of the globe. Come to the stable or it's called the stable or resident defects. Recently, it's been terminology changed from stable to the resident defects. The resident defects are defects which are not that harmful, which are been tested during the manufacturing stage or during the welding or because of the equipments. It has been already tested and withstanding to the particular pressure requirements. Hence, these are treated as a stable or resident defects. So over a period of time, it doesn't have much effect because they will be treated as a harmless with reference to time. And third category is the time dependent, because this is very important areas where we had already seen that slide. The third party damage is one of the biggest issues. It can happen the day you commission the pipeline. It can happen after 1 month. It can after 1 year. So we never know. You don't have any control. So the damages can be done by the first party, second party, or third party. So anything can happen, or it can be sabotage also if you are in vulnerable areas. And second most important is incorrect operations, because people is nothing to do with the time, because people may operate wrongly beyond its design conditions, design its maximum allowable operating pressures. So then things can go wrong. So that's the reason why it is categorized under time dependent. Weather related is one of the major concerns, because of late we find a lot of deaths because of lightning and the floods and a lot of disasters, natural disasters. So if the pipelines is in this type of areas where we need to be more careful while looking into this type of threats. That depends on the area of the pipeline. So the integrity methods is again we have hydro test, inline inspection, and direct assessment. We need to see, because hydro test is not possible after commissioning. This is all possible in only before commissioning of the pipeline. Once it's the commission, hydro test will become a big issue. You can't stop the supply of gas, so that you can do that hydro test, which is very rarely possible that where you can do the hydro test after commissioning. So the best possible is the ILI, which we can do it very easily because all the pipelines wherever is applicable. ILI is the best thing to do it. And there are pipelines where, especially the small pipelines, not cross-country pipelines, where you don't have the pigging facilities, or the pipelines which is done very long back, 20, 30 years back. That they better to go for the direct assessment. So there are again IC, EC, and SEC based on the nature of the defects identified. You can apply there. So hydro test, pressure testing demonstrate the integrity of the pipeline, but provide no information on the remaining anomalies. So it's like something is a pass or failed. So that's what your hydro test will always tell. It's a go or no go test type. But it is always is better. You know that, I think, because it is tested at 1.4 times of the design pressure. So there is always a comfort in operator's mind that it has been tested with water. It must therefore be repeated periodically. So if you want to go for hydro test, because you do it after 5 years also, again you have to do it after 5 years, because it has to be repeated over a period of time to avoid and to prevent the further failures. The higher the test pressure and the better safety margins. And in the current days, it is preferred to do the spike test even for a short while. You can do it in a few minutes, but you do it at the maximum pressure is available, 90% SMOS, or even it can go 95% or even 100%, subject to that what you agreement you have with the line pipe manufacturers. So inline inspection tools take indirect measurements of the pipeline defects, because basically it is done through the magnetic flux leakage method. Through experience, we can qualify the level of tools impressions, but we cannot remove it by ALI. We will give only where you have loss of thickness, either inside or outside. So based on which you can adopt the proper repair and rectification methodology. While adopting ILI for health checkup of the pipeline, we must consider the proper tools, because which is very, very important, because people should not just blindly do it, because there are so many ILIs which is in the name of the tool in the name of ILI, but there is accuracy requirement, there's a limitations which should understand for effective results of your pipeline, the project specifics. So this is a table which defines very clearly which type of tool give what type of defects, because corrosion, axial cracks, dents, laminations, mill defects, ovalities. So based on this, you have to decide the type of tools, or you want to identify the cracks, or the geometry tools if it is a dents or external damages. So cracks normally can be better to go for EMAT, or this ultrasonic detection tools is also available. So they are because ultrasonic has a limitation, because they need some lubricant for that, but EMAT is much more preferred to identify the cracks. It's again depends on that. So external corrosion is one of the serious concern, the threat we find. Though we have external corrosion is managed to proper protective coatings like 3-layer PE, fusion bonded epoxy, dual layer, various types of coatings is there at the pipe mill itself. And subsequently, we have to do that temporary cathodic protection till the permanent cathodic protection is commissioned. It's a general phenomena we've seen that the people just ignore the TCP even after lowering for so many months. So that's very, very dangerous. So that's what the information of the data is required to implement proper IMS. So though the pipelines having impress cost methods and efficiency and effectiveness to be verified through subject matter experts, through audits or field verifications. And internal corrosion is one of the serious concern, where it's happened mainly due to the poor gas quality. If there is a quality of gas is not proper, it has to be identified as off-spec gas, and then people should not accept that, so that to avoid internal corrosion, because it's a serious problem, but it can be easily managed. Stress corrosion cracking mechanism is mainly assisted by the environment. This happens like a fire triangle, the three parameters: susceptible materials, corrosive environment, and tensile strength. Because this is mainly happened because of the quality of soil around. And if you don't have proper data and sufficient data, you should not apply SCC. So it's a fine line cracks you find on this. So the important after applying all these things is the response to this, because it is very, very important. You know that you have done something and you have to apply the proper repair method. If the loss of metal is 80%, you have to do immediate repair or reduce operating pressures. Or if it is normal, you do it scheduled repairs within 60 to 180, or monitor to the next this thing. So to sum up the session for today, what I can confidently say, the global experience demonstrates reduction of pipeline failures by adopting pipeline integrity management system. All activities that are going to affect the safety and integrity of the pipeline system shall be performed by qualified and experienced personnel. This is very, very important. High consequence areas shall be identified on each section of the pipeline. That is up to the operators to carry out and apply all the threads in each high consequence areas. And pipeline operators shall share the learnings by experience of IMS implementation with other industry members through seminars or conference or workshops, or through some education various means, so that it will be useful, and then the same mistakes other operator is not going to do it. The sound O&M practices, legal and ethical responsibilities will ultimately increase the public confidence. So with this, I sum up the conference, and thank you very much for your patience. And now I request the audience to raise the questions. Thank you.